Have you ever looked at the moon and wondered how it got there? Well, buckle up, because the answer is a cosmic whodunit of epic proportions. The leading theory that astronomers and scientists have come up with is called the giant impact hypothesis. Here's the skinny. About 4.5 billion years ago, a celestial body the size of Mars, playing the role of the cosmic bowling ball, slammed into the Earth, which was minding its own business. Imagine the chaos. This enormous collision ejected a vast amount of debris into space. Over time, this debris, feeling lonely and looking for company, began to coalesce. It stuck together, gradually forming the moon we all know and love. So, the next time you gaze up at the moon, remember, it's not just a beautiful celestial body. It's a testament to the power of gravity and the enduring spirit of cosmic debris. So, the moon might be a chunk of the Earth that got knocked off. Talk about a rough berth. Ever try to jump on the moon? Me neither, but let's talk about moon gravity. Now, if you've ever watched videos of astronauts bounding around on the moon's surface, you'll know they seem to be having a jolly good time. It's like the world's best trampoline park, but without the risk of bouncing into a toddler. This is because the moon's gravity is only about 1/6 of Earth's gravity. You might be wondering, what does this mean? Well, imagine you're a weightlifter and can lift about 200 pounds on Earth. If you took your weights and your bulging muscles to the moon, you'd be able to lift a whopping 1,200 pounds. That's 6 times the weight. But before you start planning your moon-based weightlifting career, let's discuss how this difference in gravity affects something a bit closer to home: our tides. You see, the moon's gravitational pull is a bit like a cosmic tug of war with the Earth. It's constantly pulling at our oceans, causing them to bulge out towards it. This creates a high tide on the side of Earth closest to the moon, but it doesn't stop there. The moon's gravity also pulls Earth itself, causing the ocean on the opposite side to bulge out as well. This results in 2 high tides each day. However, the moon's gravity isn't the only player in this game. Earth's gravity also plays a role, affecting the size and timing of the tides. It's a perfectly choreographed dance between our planet and its moon, a dance that's been going on for billions of years. So you see, the moon's gravity does more than just make astronauts look like they're filming a slow-motion action movie. It plays a crucial role in the rhythm of our planet, affecting everything from the tides to the behavior of marine animals. So, the next time you're at the beach, you can thank our moon for those lovely waves. Ever heard the saying, "I need some space"? Well, on the moon there's plenty of it. Let's dive into the lunar atmosphere, or rather, the lack thereof. You see, our moon is a bit of an oddball. It doesn't have an atmosphere. Yes, you heard that right. When we talk about the moon's atmosphere, it's like talking about my pet unicorn's eating habits, non-existent. Now, why is this lack of atmosphere such a big deal, you ask? Well, it's primarily responsible for 2 major lunar phenomena. The first is the moon's extreme temperature swings. With no atmosphere to regulate temperature, the moon is like a rebellious teenager who can't decide what to wear. When it's basking in the sunlight, it can reach temperatures of about 260 degrees Fahrenheit, hotter than a summer day in Death Valley. But when it's nighttime, or when the moon is in the shadow of the Earth, it can plunge to minus 280 degrees Fahrenheit, colder than a polar bear's toenails. The second major consequence of the moon's lack of atmosphere is that it can't carry sound. That's right, folks. On the moon, no one can hear you scream, or laugh, or even make a bad pun. Sound needs a medium to travel through, like air or water. But on the moon, there's nothing to carry the sound waves. So it's not just silent, it's dead silent. Imagine for a moment, you're on the moon, standing next to Neil Armstrong as he takes that famous one small step. You'd see his lips moving, but you wouldn't hear a sound. You'd be standing in the middle of one of humanity's greatest achievements, and it would be as quiet as a library on a Sunday morning. So, the next time you're enjoying a quiet moment, remember, it could be quieter. And the next time you're roasting or freezing, remember, it could be more extreme. Because on the moon, there's no atmosphere drama, just a whole lot of space. So, if someone tells you they heard a scream on the moon, they're pulling your leg, my friend. Have you ever wondered what's on the dark side of the moon? Well, let's clear up a common misconception first. There really isn't a perpetual dark side. The moon is tidally locked with our planet Earth, which means it rotates on its axis at the same rate that it orbits our home. This synchronization creates an illusion, making us believe that the moon is a celestial body with a permanent poker face, never revealing what it's hiding behind. But here's the twist in our lunar tale. The so-called dark side isn't shrouded in eternal night. It experiences a day-night cycle just like the side we see, only it's out of sync with ours. While we gaze upon the moon's familiar face bathed in sunlight, the far side is having its midnight moment. And when it's daytime on the far side, we see the moon's darkened visage. This elusive far side is often incorrectly referred to as the dark side, perhaps thanks to a certain popular rock album. But let's not get comfortably numb about this. It's more accurate to call it the far side of the moon, as it's just the side that's always facing away from us. It's a realm of the moon that's been less studied simply because it's harder to reach and observe. But it holds potential for future exploration and maybe even colonization. So, if you're planning a secret moon base, the far side might be your best bet. Thirsty on the moon? You might be in luck. You've probably heard the saying that the moon is as dry as a bone, right? Well, hold on to your hats because that's all about to change. Recent advancements in technology have allowed our scientists to detect water ice on the moon, hidden away deep in permanently shadowed craters. Yes, you heard it right. There's ice on the moon, folks. This discovery was quite the shocker. Imagine all this time, we've been looking up at that big dusty cheese ball in the sky, thinking it's as dry as my Aunt Matilda's fruitcake. But lo and behold, it's been hiding a secret stash of ice all along, just like your uncle at family reunions. Now, you might be wondering, what's the big deal about a little bit of ice? Well, the presence of water ice on the moon is a game changer for future lunar habitation. It means we could potentially use this resource to support human life, for drinking water of course, but also to create breathable air and even rocket fuel. This could drastically reduce the amount of resources that future moon missions would need to carry from Earth, so the next time someone tells you the moon is dry, you can tell them to check their facts, or better yet, invite them for a lunar ice cocktail. How's that for a moonshot? Ever feel like the moon is drifting away from you? It is. Yes, you heard that right. Our celestial companion, the moon, is slowly but surely moving away from us. It's not packing up its craters and leaving in a huff, but it is inching away at a rate of about 1.5 inches per year. That's about the same speed as your fingernails grow. So, in the grand scheme of things, it's a snail's pace, but it's happening nonetheless. This lunar distancing act is due to a gravitational dance between the Earth and the moon, known as tidal friction. It's a bit like a push-pull game where the Earth's gravity pulls on the moon, creating tides, and the moon's gravity pulls back, causing the Earth's rotation to slow down. This slowdown creates a little extra push, which sends the moon drifting away. But what does this mean for our future? Will we wake up one day to find the moon just a tiny speck in the sky? Well, not exactly. Even at its current rate, it would take billions of years for the moon to noticeably distance itself from us. But it does have some interesting implications for Earth's tides and solar eclipses. Right now, the moon plays a big role in creating our tides. If it were to drift away significantly, our tides would become much smaller. That's a pretty big deal for all the oceanic life that relies on tides. And it's not just the sea creatures, coastal communities and industries like fishing and shipping would also be affected. Solar eclipses too would become a thing of the past. Right now, the moon is at just the right distance to perfectly block out the sun during a total solar eclipse. But as the moon moves away, it'll appear smaller from Earth, and we'll no longer have total solar eclipses, only partial ones. So, enjoy those supermoons while you can, folks. Because our moon, like that distant relative who only visits on holidays, is slowly but surely saying its long goodbye.